aim of this experiment is to improve the quality of data set before applying machine learning algorithms. Real-world data set often contains missing values, duplicate records, outliers, and categorical data that cannot be directly used by machine learning models. In this experiment, we'll perform different data processing techniques such as handling missing values, removing unnecessary columns, detecting and removing outliers, checking duplicate records, normalizing numerical data, and encoding categorical variables. Here first we import all the necessary libraries we need such as pandas, NumPy, Matplotlib, scipy.stats, and Escalent preprocessing, etc. And this is used to upload the dataset file, that is the CSV file. Here df equal to pd.read underscore csv, the file name, the dataset file name store1b.csv is used to load the dataset, and df.head is used to display the first five rows of the dataset. Then missing percentage is equal to df.isNull.sum. This code calculates the percentage of missing values in every column. Is null is used to check missing values and sum counts them. Then this line says that here missing values in the quarterly tax column are replaced using mean values. Mean is commonly used for numerical columns because it keeps the overall distribution of data relatively unchanged. Here, the branch column contains categorical data. Missing values are replaced using code, which is the most frequently occurring category. And this is the output we get for it. And then in here's some sometimes a column is unnecessary for analysis. The drop function removes the product line column from the dataset. After removing it, temp underscore df.shape is used to show the updated dataset. The z-score measures how far value is from the mean. So this line indicates it. Then if the score value is greater than 3, then the value is considered as an outlier. The rows are removed using the drop function. And then the output, the dataset size is 47, 15. And here df.duplicate.sum, this counts duplicate rows in the dataset. The percentage of duplicate record is then calculated. Duplicate records can be introduced as bias and should be removed. So here duplicates, temp underscore df dot duplicate subsets is equal to, instead of checking the whole rows, duplicates are identified based on the selected important columns. The duplicate rows are removed and the updated dataset size is displayed. So the importance are used are chosen like customers, product line, age, gender. And this is temp.rdf.shape is used to display the updated dataset. So the scales here, the min max scales the value between 0 to 1. Normalization ensures that the features with large values do not dominate smaller ones during machine learning. So the normalization values are visualized using the scatter plot here. So it has normalized age and index, and this is the plot we have got. This is the scatter plot by using this matplot. Here, this code explains that this standardizes the data, like mean becomes 0 and standard deviation becomes 1. It is useful for algorithms that assumes normally distributed data, and the scatter plot visualized is here. Z-score normalization of age is Z-score index. So this and this is the scatter plot displayed. And here This LE is equal to label encoder, and this line indicates that machine learning model cannot understand text values. So label encoding converts categorical categories such as cash, card, UPI, credit card, etc. into numerical values like 20122, etc. These are the numerical values. This prevents one numerical value of each category. So next is pd dot concat pd dot get dummies. Instead of assigning numbers, one for encoding creates a separate column for each category. Examples like cash, card, UPI, like tax, total payment, and becomes payment of cash, payment of card, payment of credit, payment of e-wallet, quarterly tax, price, payment of cash, etc. Each rows contain either zeros or one, that is false or true, indicating whether the category is present or not. This avoids introducing an artificial ordering among the categories.